So, welcome to Developing AI Strategies. What is Artificial Intelligence slideshow. So let's look at what AI actually is. So it's described as the simulation of human intelligence by machines. And an easy way to think about this is to consider how human intelligence and animal abilities have evolved through our interactions with the natural environment over thousands and millions of years. In a similar way, millions of cycles that AI makes through its training data will shape the way that it develops and lead to these specialist AI models, which is what we're going to be looking at. In recent years, AI has become extremely effective in reasoning, learning, problem solving, and using language. To do this, AI uses huge quantities of data. So algorithms will work through this data to identify patterns and use those patterns in order to make decisions. That data is fed back into the system to improve its quality, perform tasks more efficiently, and to allow the software to learn and develop more impactful results. So to better understand AI, it helps to break it down into 4 different types. The first type we'll be looking at is the simplest, that's reactive AI. So this is known as foundational machine learning models, which we'll be getting more into later. One example, which I think a lot of us will be familiar with, is Netflix recommendations. So Netflix will collect data from a customer's account and look at their viewing history and use that to be able to formulate and predict what they think their customer will also want to watch. And of course, anyone familiar with this will know that this isn't always perfect. So it's got imperfect information as it's not really capable of understanding new scenarios or how your tastes might change based on something you've seen that isn't on Netflix. And it also won't improve with more data. Unlike the second version that we'll be looking at, which is limited memory. So unlike reactive AI, limited memory can gather historical data and monitor specific objects or situations over time. So that allows it to make real-time decisions, such as the ones that we see that performed by self-driving cars, which are based on past and current data. This data isn't saved into any particular AI memory, but it's able to gather more data and be trained and transform the way that it makes decisions. The third version is theory of mind, which does not yet exist, but it's important to consider because this is the way a lot of technology is heading. So once it's developed, or if it is developed, theory of mind AI could have the potential to understand the world and how other entities have thoughts and emotions, and in turn, how their behavior will be impacted by those around them. So in the future, they could perhaps understand intentions and predict behavior in a way to simulate human relationships. And the fourth and final is self-aware AI, which similarly does not yet exist. But once it does, it will bypass human intelligence. So one way of looking at this is to consider that it understands its state of being and senses or predicts others' feelings. For example, I am happy would become I know I am happy, or because I am happy I will dance. So let's move away from that and look at how AI can actually be used. So the first one we consider is machine learning. So these are algorithms that mimic human learning, and these are the simplest versions of AI, which include translation and chatbots, text-to-speech and fraud detection. Beyond that, we get to deep learning, which includes autonomous vehicles, image recognition, face ID, and predictive analytics. And finally, generative AI, which is the most sophisticated version of AI, and includes voice cloning, content generation, video generation, and music composition. So let's go back to machine learning, because this is a really important one that we will definitely be using at some stages later in this course. Supervised learning is one type of machine learning, and that includes the user feeds the algorithm information to help it learn. The algorithm you provide the machine is labeled data. And unsupervised learning finds hidden patterns in unlabeled data. Finally, reinforcement learning. The algorithm or agent uses and learns by interacting with the environment and getting a positive or negative reward. So I'll take my face off the screen now, and we can look at this particular design, which is a way to demonstrate what we've just been going through. So deep learning sits inside machine learning, which sits inside of artificial intelligence. And just to clarify, artificial intelligence is the development of a computer system which is able to perform all the given tasks on par with human intelligence. Machine learning is a subset of AI which contains statistical algorithms which enable machines to improve the tasks with experience. As opposed to deep learning, machine learning models need human intervention to improve accuracy. Deep learning is a kind of machine learning which has a human brain-like structure which works on the basis of logical assembly of algorithms which are known as neural networks. That's for something a little later. Finally, all AI that we've been talking about requires infrastructure. So we need large amounts of computational power to be able to go through the amounts of data that we need to get through to find the patterns that we can be able to learn from and be able to feed back into the AI networks to be able to improve their quality and the impact of their results. This is done through CPU, which is the most popular computer platform, GPU, which is used for training machine learning and deep learning other algorithms, and TPU, which is tensor units, accelerators that have been custom built to speed computations in AI workloads for deep learning applications. So finally, in conclusion, AI is computer software that mimics the ways that humans think in order to perform complex tasks such as analyzing, reasoning, and learning. Machine learning is a subset of AI that uses algorithms trained on data to produce models that can perform such complex tasks. So with these combinations, with the technology and the data and the infrastructure and the knowledge, AI can be incorporated into almost every type of industry and workplace. Finally, here are some references that I used to be able to put together this presentation. Thank you very much for watching.